Welcome to your lesson on drawing circuits. I'll try to get into it and go through it as quickly as we can. First of all, I'd like to introduce just a couple of new symbols that you haven't seen before. The first one would be the fuse up here at the top. The fuse is a little tiny thin piece of metal. We draw it like a little squiggly here. Up first, then down, please. And basically what this does is if the circuit begins to heat up because there's too much electricity in the wire, then the wires are going to possibly melt. And you don't want to either melt the wires and cause a fire in the house or to damage one of your loads, whether it be a motor or a light bulb or whatever it is that's on there. You don't want to damage it. So what will happen is if the wires do begin to heat up, this little thin piece of metal will actually melt. It's designed to melt so that if this piece of wire and this piece of wire gets too hot and sending heat through there, when it melts, it breaks the circuit. And if it breaks the circuit, it saves the light bulb or the motor or whatever else you've got on there. It saves them from being damaged by too much current. So fuses are very important for safety. You guys have fuses in your house. Literally every safety panel in your house will have some kind of version of a fuse. Now in your house, you might have the little glass fuses like I do in my house, or you might have a complete circuit breaker which can be reset and reused. Fuses can only be used one time and they have to be tossed, but a circuit breaker is much nicer. We use this symbol though for fuses to show that there's a safety fuse in the wire. The other one that you haven't seen before is called a ground connection. Basically you just have the wire going into ground. That's basically what it shows. We're not going to do any pictures that actually need to use this. I just wanted to show you what it looked like. Two other things, an ammeter, which we started talking about when we talked about current, and a voltmeter, which is how we measure the potential difference in the wire. And we'll get into more about how to measure ammeters and how to calculate the amperage, and the same thing with the volts, how to calculate the number of volts and all that kind of stuff, but that's for another lesson. Let's get into drawing these guys. So please make sure you're using a pencil. It's always nice to use a pencil because if you make a mistake, it's easier to fix. So please make sure you're using a pencil. Ruler, if you aren't too neat with your lines, then yeah, grab a ruler. If not, I'll still accept things without a ruler, but it is good practice. I can't use a ruler because I'm doing this on an iPad, so it'll just have to be what it'll be. And then of course you want to demonstrate that you can draw the correct symbols. You choose the right symbols to draw the circuits. Okay, so the simple circuit, anytime you see simple circuit, what they mean is that this circuit is in series. In series means that there's only one pathway, and any load or switch or anything like that must be on the same pathway. Now in this case, we've got one load and it's controlled by a switch. So if it just says load, you can choose what load you want, whether you want it to be a light bulb or a motor or whatever. I'll probably just do a motor for this one, but you can do what you want to do. So it's one load that is controlled by a switch. Keep in mind, you need to always have a power source. Okay, this is a single cell. I can do double cell if I want. This would be a double. I could even do a triple cell if I wanted. The more cells I put in there, the more power I've got. So what one load that's controlled by a switch. So I don't know why I always just like to go clockwise, and I usually draw my switches like that. And then there's one load, so I'll just put the load down here. There's my motor, and then I combine it and draw it like that. Okay, need a series circuit. Number 2, which is down here. Number 2, we got 2 light bulbs that share the electricity. The circuit is always on. So if it's always on, whoops. So we've got 2 light bulbs sharing the electricity. That means it's in a series circuit, and it's a double cell battery. So I need to make sure I draw at least 2 cells. And the circuit is always on. So there's no switch. I don't need to worry about a switch for this one. So let's quickly draw the sucker. So 2 double cell battery. Again, I always like to start with the power. Double cell. Circuit's always on. 2 light bulbs. So I like to draw the circles first. Then I like to draw the wires. And when I get up to the light bulb, I draw the little light bulb L. And then I can complete the circuit. I always go back and make sure that I read it again. So I've got my double cell battery, check. I've got my 2 light bulbs, check, check. and the circuit is always on. Yep, there's no switch or anything. I'm good to go. I'm done. Next one, number 3, which is up here. So 3 light bulbs and a power source. 3 light bulbs and a power source. Okay. Notice it didn't say power source back here, but it did say double cell battery. Never mind. We got 2 bulbs that are dim. That tells me that they must be in series to one another because they're sharing the electricity. And then one has full brightness, which means it must be in parallel because it has its own path to the battery. It's getting full access to the battery. So I'm going to need what's called a combination circuit. Okay. So let's draw this one. So we need a power source. Let's make it a triple cell just for fun. 1, 2, 3. 2 are dim, so I know that they are in shared pathway. And 1 is full brightness, so it must be in its own pathway. It doesn't say anything about a switch, so I'm not going to worry about it. I always go to the outside one first when I'm drawing these lines. That way I don't have to worry about lines being broken. And then through there, through there. Okay, so let's check it one more time and make sure that it makes sense. We've got 3 bulbs, check. And a power source, check. 2 bulbs are dim, those are those 2. And 1 is full brightness, that's that one. I'm done. Okay, on to the next one. 2 light bulbs with equal brightness. That means that they must have equal access to the battery. That can be controlled by separate switches. So I must have 1 switch for each light bulb on its separate pathway. I'm going to need a parallel circuit to do this. Now, this is where switches get a little bit trickier. You have to make sure that they are only in the unique branch. So let's draw our power first. Let's just do a single cell this time. That means I'm going to have a light bulb and another light bulb. Okay. I'm going to have a switch in this light bulb's pathway. And I'm going to have a switch in this light bulb's pathway. And I'm going to draw it out to the outside one first. Draw my little L. Draw my little L. And complete the circuit. Okay. Now, here's the thing. This is the correct answer here. I'm going to draw in a different color what would be the wrong answer. If I was to put a switch here in the pathway, okay, this switch, because of the way that the path is developed, if the electricity comes out of here and goes through, it'll go through that switch before it reaches that branch and before it reaches that branch. So putting a switch here is going to control the entire circuit. So it's important that when you put in this, let me just grab my little thing here. When you put in the switches, then you want to put them in the unique pathway right here so that it only controls this pathway. And then this switch only controls this branch. Okay, that way this light can be on and this light can be on at the same time. All right, next question. The hall, oops. The hall light in your friend's house can be controlled by 2 switches. Well, if it's one light being controlled by 2 different switches, it means those switches have to be on the same pathway as the light bulb. All 3 are on the same pathway. That makes it a series. Okay, so 1 at each end of the hall. How do you do your diagram? Well, it's simple. This is actually easier than it sounds. So here we're going to do power source. Okay, obviously you're going to have more than in one single cell, one to light your house, but we'll just draw it as one power source, no problem. Okay, that means that I've got a switch at one end of the hall, and I've got a switch at the other end of the hall. Okay. And both switches are going to control the same light bulb. Done. 2 switches, 1 light bulb, finito. Okay, let's do the next one together. So now you've got a closed parallel circuit. That means that our switch has to be closed this time. Got a single dry cell, that's easy. One of the motors can be turned on or off. Okay, so there must be a switch in that motor's pathway. And then two motors are always turned on, so there's no switch in that pathway. We're going to need a parallel circuit. Now, we have a couple options. I'll show them to you. One way to interpret this one is to say that the first motor has its own pathway and the other two motors share a pathway, so it could be a combination circuit, or all three motors have their own pathway and I just don't have any switches. So I'm going to draw both of those for you. So first of all, we draw our single dry cell. Okay, I know that this motor needs to have its own switch, and it is a completed circuit, so I know the switch is closed. Okay, then I could have each motor on its own pathway. So I can go like so. This is where a ruler comes in handy, but I don't have one. Okay, so that's one interpretation of it. You can see that we've got our one motor, so one of the motors turned on and off, one motor turned on and off, and then two motors that are always turned on. There's no switch in these unique pathways here, so it's always on. And then the other way I can interpret it is I have my dry cell and I have my motor with its switch, and again make sure it's completed, but then perhaps these two motors are actually on the same branch. And both of these would get you correct answers because they aren't very super explicit about where those two motors are. So both of those are perfectly good answers for this particular question. Okay, next question. Two motors, two light bulbs, and a power source. We're getting fancy here. There's a fuse. That's important. Notice that it says it protects the entire circuit. That means that that fuse has to be in the common pathway for all of these. Just put it next to the power source. That's the easiest way. So that the power has to go through that fuse before it ever reaches any of these loads. Okay. The light bulbs are controlled separately from the motors. All right. That tells us that the lights are in series to each other. Okay. They're controlled separately from the motors. When you unscrew one light bulb, the other light bulb will also go out. That's how I know they're in series. And the motors are going to stay on. So give the lights their own pathway, give the motors a different pathway, and then there's no switch. It's just that when the light bulb gets unscrewed, so there's no switch mentioned. Okay, it's going to need a combination circuit. Let's get this one done quickly. So motors and power source. Didn't tell us how big the power source was, so let's just do a single dry cell. Okay. We're going to do our fuse. This is the new symbol I showed you at the beginning. You go up, down, and then back to level. So make sure you do a nice little S-bend curve like that. So there's our fuse protecting the whole thing. Then you have your light bulbs controlled separately from the motors, and the light bulbs are in series to each other. So draw my two light bulbs here in series to each other. And then I've got my motors. So again, the motors can do the same thing that we did in the question before. The motors could be on separate paths, like so. So then we would have come out, go down, back around, draw our little L's, and then draw the separate pathway. So we could have a completely parallel motors, or we could have, make sure we put our fuse back in, up, down, up. We could have the two lights being in series, and then the two motors could also be in series to each other. They are not explicit enough in this question for us to know for sure how the motors are actually wired. We just know for sure how the lights are wired. Okay, so both of those are equally great. You just need to make sure that the motors are separate. These motors have to be separate from the lights. So whether they're separate but together from the lights, or whether they're separate from each other, doesn't really matter. Both of these are correct. Okay. One final question for practice, more of a thought question. So you've got Christmas lights being put up at your house, and you notice one of the bulbs does not work when the rest of them do. Is it wired in series or parallel? Well, I hope you know already that it must be wired in parallel, because if the one bulb has gone out, the other bulbs all still work. So they must have their own pathway to the power. Okay, so you're going to write it down in some way like that. You want to say something about the idea that since since the other bulbs have their own pathway to the power source, this must be wired in parallel. All right. Now, if you guys could continue on, you're going to be completing these questions here. If you could make sure that once you finished drawing them all, if you could take a quick picture of your work, make sure you label them 1, 2, 3, 4, 5, 6 so I know what you're doing, and make sure you put your name on your picture, please, so I can tell. Please be very neat. This is where using a ruler and a pencil would be a great idea. And get a picture of that and send it to me on the Google Classroom, and you are done. There will be a couple other little booklet worksheets attached to this lesson. You just need to make sure you get those ones done as well. All right, let me know if you have any questions.